on the project demo. So firstly, this program here is running the monitoring system, and this program here is running the charge and discharge system. So this TV here is actually showing the NI web server as mentioned by Wenshi just now. So maybe I'll just start on by introducing you to what this is first. So this is the acrylic board that I said just now. We actually laser design this and then we laser cut. So this is the board that is measuring the batteries, and this cover here is actually 3D printed. So this orange wire here is connecting the box to the relays before we connect them to the batteries. And this is the battery box. So this load here is the load that NCA program is using that view. And this is the power supply. And this is the 4G router, and the GSM modem is right here. So this is the MyRadio, and right here is the thermistor circuit that is measuring the cell temperature, and this is the circuit that is powering up the relays. And we have drawn power from the external power supply. So in the event of emergency, you can just press the e-stop, and this is the converter box. So this is the battery box. Maybe you can. So if you open up, you can see that all the batteries are connected inside. We have two stacks. So the bottom stack is 12 cells, and on top is 12 cells. The blue board is the active balancing board. Yeah, so I'll pass on my time to Wenshi to show the discharging program.
So this is a 4-channel discharging tool. Then for the electronic itself, there are 4 channels also. So you can monitor 4 channels. Currently, you are using only channel 3 itself. Carry out discharge there. So after you just set up everything here from discharge current, also the range of discharging current, trigger current, 1 ampere example I said. And the load is start on after the channel start. After you start conduct the discharge test also. You can see here you are remoting, so you can, from here you can see the battery side is reading voltage, right? Because they are releasing energy out from the battery. And you can see the curve from here is also start discharging right now. So from curve also, then we can also sense the temperature itself. The ambient temperature, our current temperature is about 25 degrees, so it match our environment temperature. So in any case, I power fade, overpower, overcurrent, over voltage, right? In order to prevent the system. Also internally there will be a protection is for trigger, but now it's in a smooth. But if furthermore you want more protection, you can just press the stop button itself. And you'll see everything will stop. All the load itself will off, all the voltage will be reduced. And this will help with protect battery. And now pass the matter to Jogan, you talk more about charging. So what you want?
So this is where I set the charging configuration. So firstly, I can set the over voltage value and overcurrent value. So I can also set the charging current and charging voltage. So because we are using 12 cells and the full charge for one cell is 4.2 volts, so there will be 12 times 4.2 volts, which is 54.4 volts which I have set here. And the current I set will be 0.2 C at 0.68 amps. So for the discharge voltage is where I set the over discharge voltage, then it goes to the pre-charge voltage. And the current current is 4% of the initial charging current, which is 0.6 amps. So I just need to press this and press this. And if I run it, it will start the charging process. And this can be monitored using a Wenshi system. You see that the voltage has to rise. And right now the power supply, the voltage is increasing. So this means that it's charging the whole battery pack right now. I'll now pass on my time to Wenshi to share more about his monitoring system.
So I'll now talk about the monitoring systems for voltage and surface temperature of the batteries. So this is the main level dashboard that you guys saw during the presentation. So here we have the board 1 and board 2. So this represents DC2259A board 1 and board 2 because we change two boards. So here we have the voltage indicator and the temperature indicator, and we also have an indicator to indicate whether if the readings are normal. And it's the same on the NI web server dashboard as well. On the threshold setting, we've set the over voltage to 4.2 volt, under voltage to 2.5 volt, and over temperature to 40 degrees. So if any of these readings are exceeded from the batteries, so it will actually trigger the system warning. So I'll now demonstrate the system warning using this hairdryer right here. So as you can see, we set the over temperature threshold setting to 40 degrees. So if any of the readings from the thermistors exceeded 40 degrees, the system warning will be tripped. And an SMS message will also be sent to me by this modem device right here. So I'll put my phone right on my phone with Jie, and I'll blow at the thermistor. So as you can see, let me blow some.
See there's a message coming, warning message.
Okay, so as you can see right here, it has exceeded the over temperature threshold value, and the system warning will be triggered. So now the relays connected in between the DC2259 board and the batteries are actually open. So to ensure the board's safety, and also a very annoying buzzer will be turned on to inform the users about a fault that's happened. So as you can see, and there's also a system warning SMS message sent by the modem. And so as you can see right now, all the readings are normal, are back to normal again. So now the users can just reset and turn off the warning. Thank you.
And once this system activates, all the problem will stop. Everything will start itself.
You all have been doing a lot of things in like individual. But what's the whole purpose of this project? Cell monitoring. But what's the conclusion after doing all this? What are you supposed to do?
Testing the battery. For now, it's like repurposing the battery. So usually battery is found in many cells, right? With different cells and different characteristics. Also maybe similar characteristics. But for us to do repurposing of battery, right? We know maybe like old battery. We need to test our individual cell to see whether is it in good condition or similar characteristics. So during the cell discharging, we can find the example. We can find the discharging curve, right? Similar characteristics. And once the characteristics are matched together, we can recombine all the cells, workable cells together and make a second-hand battery for as a storage system, for solar. So for monitoring itself, we need to monitor individual cell. As say, we need to monitor battery are from many cells together. And individual cell you can match the same characteristic also. Then this will help you. If as a different characteristics match together, maybe like we'll use the battery, some of the cell will be over discharged. Some of them maybe when do charging, some of the cell will be overcharged, right? And this one will affect the whole performance of the second-hand battery. Therefore, we need to collect all the data using our system so that when you do recombine the battery itself, right? This will help to see whether the battery is good, usable or not. Is it matched with the client's requirement also.
When you recombine, is it in cell level or in pack level?
In pack level.
Because
In pack level, but your monitoring is in cell level.
Per cell.
we measure them per cell as the one pack of batteries can be made out of many cells. So
Yeah, so that's why I said when you after you select those good ones, you pack them together. Do you monitor them as a pack or as individual cells?
of course we monitor them as individual cells. Then when we found that certain cells are not as good,
Not up to standard.
Yes, not up to standard.
Yeah.
Then those cells really cannot be
But
used.
monitoring is not for you to check whether it's good. Just now the state of charge, all these are for you to pick out all the not good one, right?
That's why we need to do data analysis as shown during the
Yeah, so
presentation.
monitoring is not the one that tell you which battery is good. This is telling the battery condition only, right? It's not for you to check which battery is good. Which battery is good is done by the state of charge and the discharge
Discharge.
and all this, right?
Mm.
Then once you pick up all those individual one, you pack them together, right? So how you monitor them? Is it individual cell or as a
As a pack, using like maybe charging, using
yeah, so
charging.
as a pack, then your this monitoring won't work already because it's individual cell monitoring. So it's in the pack. Normally when you pack them together already, how you test your battery? Like I want a 24-volt battery. Individual trees, you put them series parallel together as a whole pack already, right? Then you will monitor the whole pack health, right? Not individual
Yeah,
cell.
compared to we can use our charging and discharging system. We get the
Yeah, so that's why I want to know the purpose of the monitoring system.
From Google monitor to monitor a specific cell itself. Because maybe it's cause unbalance or maybe like over discharge the cell. Maybe this cell will be not reach a standard. You can simply remove this cell and replace a new cell inside. Maybe like industry, maybe some the client want to use a old battery gun, but they just like change some of the cell in the battery. They can just use this monitor itself to monitor all the cell inside the battery. And for example, maybe this battery is only got 2 damage cells. You can just simply take out 2 damage and replace a similar cell with similar characteristics together. After they like recombine, reuse it again. This also can help them to save the cost also. Maybe they will not necessarily to throw the whole battery. You only some of the cell inside the battery. Whole back, yeah.
So now your battery is, your system can monitor 12 cells,
24
24
cells.
cells.
24 cells.
Yes. Yeah, you can see from
Like,
inside.
is it plug and play, like I slot in, then
Yeah.
take out?
Yes,
Yeah.
yes.
Yeah.
Because I saw your thermistor is directly mounted onto the battery.
You
So
can-
Then how you going to plug in, pick up so easily?
yeah, so when we need to plug in, take out, we will need to
So
obviously
it's
need
not
to
so
unpaste.
straightforward lah.
Uh,
Because if it's
Yeah.
straightforward, I straight away plug in, it's supposed to do everything.
Mm,
Some
yeah.
more now it's directly mounted onto the insulator also. So is there any thermal thermal difference between the metal part of the battery, and because now it's wrapped with one plastic, right? I saw. Thing.
Yeah. So the inside the thermistors, right? The thermistor itself is actually exposed to the onto the surface of the batteries
So
directly.
you all scrape off the
yes. We
insulation part.
scrape off the insulation part, so we just paste the.
Then it's not so straightforward anymore. You have to scrape off, put the thermistor, then mount onto it.
yeah.
How you test 100 battery in one day? Not possible.
Well, actually, there is another way that we thought of. So we can actually insert the thermistor underneath the batteries, so that we block out. It won't affect the
Or you
thermistor.
still need to scrape off?
No need. You just put below. Then
But got insulation, the batteries. How are you going to measure accurately and yet very fast? You know how you test 100 battery? Your car battery, you know how many pieces?
we know.
500 over
But now
pieces.
it's a limit.
Then you every day
Certain
you scrap battery, put the meter, then do then start monitoring when got efficient.
Yeah, but this is we are the first batch, so everything
Yeah,
here is
from
more
scratch.
research.
Of course, there are more improvements needed.
Yeah, in the later on you improve more on the new
So what is the
system.
future work, just to add on for this project?
So the future work can be the next batch. I think they can actually use an actual load other than the electronic load.
Yeah.
Maybe they can use it in an application such as maybe use the batteries to power up a motor or something like that. And they can also increase the capacity, increase the size of the batteries. So as right now we are using 18650 size batteries. So the next batch can buy bigger and more powerful batteries.
Maybe you can get industry standard of battery for like maybe like big battery like lithium ion. So then also you can whether monitoring this one the whole battery during for the application. Well, teacher say we are using for EV, right? So maybe the next right can talk about how this monitor system can monitor EV car itself when using the battery energy, using energy for the battery. Yeah.
Furthermore, for the hardware part, I think they can work on the battery box connection because there are a lot of wires, so not very easy to think of how to connect the batteries. So they can work on that, making it more easily to take out and put back new batteries.
So who is doing what? The whole project.
What's the distribution of work? Can you share?
Monitoring, discharging, and charging.
Like what you all present.
Yes.
Okay, maybe I ask for monitoring. So that's Joven, right?
Monitoring is stuff like it. Yes.
So for your GUI part, right? You did this one and the other one, right?
Yes.
Okay, so for communication, do you talk directly to the MyReal or do you go through the PC first?
So for you mean for this web server right here?
Yeah,
Okay, so this web server
the data is taken directly from.
Yeah, so this desktop here will first collect the data from my real over there. Then afterwards, right, it is connected to the 4G router as well. So it basically runs this web server. So and I just need to connect my laptop to the 4G router, and my laptop will gain access to the same dashboard as well.
Ah,
So,
okay, yeah, that's good.
So only one MyReal, the whole system.
Yes.
Okay, then question for Joven, what's the function of the multiplexer? I mean, you have your thermistors hooked up there, right? And then how many inputs for thermistor is there on the MyReal?
Actually, the multimeter is Wensh's part, but I guess I can explain also. Actually, the Mario doesn't have
Oh,
enough.
okay, I thought
Yeah, the Mario doesn't have enough analog inputs, so we have to use Mario to increase the number of analog inputs.
Okay,
Yes.
good. So use a multiplexer, right? Input.
Analog input.
Analog input. Analog input.
Control and the digital output. How many pins?
40 digital output, I remember.
40
yeah,
digital output.
four.
Huh? Digital output?
No, digital output.
You need to use 4 then you have how many in the MyReal?
The my real 40, 45, I think. Around there. Yeah.
But the analog don't have.
Yeah, not enough analog input. That's why I need to use multiplexer.
So for the controlling of the outputs again, do you directly, just now you said 40 of them, right? 40 outputs, digital outputs to control, right? Do you use relays, isolating relays, or?
For the MyReal to talk to the analog multiplexer, we do not use. We just use just wirings only.
Just wiring, yeah.
So as the commands for the analog multiplexer are just binary numbers 0 to 15.
Okay,
So
that's good.
we just send 0 to 15 through these 4 digital outputs.
Okay.
Yes.
question?
Yeah, I have no question.